Okay, guys, I'm going to try something different tonight. I'm not going to show my mug at all tonight. So just see what happens with this recording. I've been having some problems getting videos recorded and saved properly. So hopefully this one works pretty well. So yesterday I gave you guys the assignment of doing some research on the Oklahoma City bombing. I hope you guys took that seriously because it was a pretty seminal moment in our history as a country. And then in terms of FBI and DEA and the ATF, the Alcohol, Tobacco and Firearm Agency, that was a big deal. Just trying to find domestic terrorists that were able to get their hands on that type of explosive, that amount of explosives, really set off a chain of events that really locked down the industry for quite some time, and it still is locked down. Even some chemicals that we would want to get here at Taylor High School in our lab are off limits unless we have certain permits. So it was a pretty big deal, and I hope you guys learned something from it, not just from the forensic science part of it, but just from the history of the United States and kind of some of the policies that we have in place for air travel and for the industrials and the chemical industry and things like that. So today I'm going to bring you guys a little bit of information on just basic explosives and let you guys do a little bit of research on four very common types of explosives here. So on our first slide, we see that an explosive material, also called an explosive, is a reactive substance that contains a great amount of potential energy that can produce an explosion if released suddenly, usually accompanied by production of light, heat, sound, and pressure. And the key words there, I don't know if I can draw on this one, but the key words here being potential energy, this guy right there, and if released suddenly is also key. My goodness, that's not good. So let me erase all that nonsense right there. Maybe I'll try something a little bit different here. But again, it's basically a release of potential energy in a sudden fashion. So when you think of an explosive, it's a little bit different. Gunpowder would be a type of explosive. We'll talk about that here in a second. But gunpowder in its chemical nature burns very quickly. It doesn't have that sudden potential release of energy like TNT or like dynamite or mercury fulminate, where the chemical nature, the chemical bonds that make up that chemical are wound so tight, and some of them are very, very fragile, that if they get any sort of spark, any sort of shake, any sort of, that little extra activation energy to allow them to release that energy, they'll do so in a very, very violent manner. That's the difference between an explosive material like TNT versus gunpowder or even fireworks is the suddenness. It's that sudden, how quick can that energy be released, and then how much energy is released in that one moment. This potential energy stored in an explosive material may be chemical energy, pressurized gas, or nuclear energy. Okay, and what we're going to talk about today is pretty much going to be the chemical energy of bombs and things like that. Nuclear energy, obviously, we know is the splitting or the fusion of atoms, and that generates billions and billions of times more energy than some of the bombs that we're talking about here. So when we talk about the classification of explosives, for the most part, you've got three basic classifications. You've got primary explosives, what we call low explosives, and then the high explosives. And it's pretty self-explanatory based on just the types and what they're named here. So your primary explosives are the explosives that detonate or cause a much larger type of reaction. Okay, highly sensitive. So a slight shock by fire, some of these things will explode very, very quickly. In fact, if you're a fan of the TV show Breaking Bad, I know I've talked about this before. One of the all-time scenes from that television show, and it's actually voted one of the top 10 scenes from any television show, is the scene where Walter White, the chemistry teacher that turns bad and starts making drugs, his partner is being held hostage, and Walter White goes in with what the drug dealer thinks is a bag of crystal meth. Okay, well, inside that bag is actually a drug called mercury fulminate. And the way the scene unfolds is that the drug dealer allows Walter White to grab a chunk of this mercury fulminate. He thinks it's the drug. the chemistry teacher knows it's not. And what this guy does is Walter White throws this chunk of mercury fulminate on the floor, causes a massive explosion, and all the bodyguards are kind of, they're not killed, but they're thrown off their feet, and he gains the upper hand. Eventually gets his partner back and actually makes a drug deal on the side of it. So it's one of those things where sudden shake, sudden that burst of energy creates a much larger explosion, and mercury fulminate is definitely one of those. Moving on to the high explosives, higher energy content than the primaries. The video that I supplied here about the Nobel Peace Prize and the scientist by the last name of Nobel, when he made TNT, when he made dynamite, he took nitroglycerin, which is very, very sensitive, and combined it with other chemicals and made it very, very stable. Okay, so what high explosives do is they still have that ability to be very, very dangerous. And when they release their energy, they're releasing huge amounts of energy, massive fireballs, huge shock waves, concussion waves that can kill a person, but they are stable at the same time. Okay, they can be shaken and jostled and thrown off in the video, he throws a box of dynamite off the roof of his shop and nothing happens. Okay, very stable. So there's got to be some sort of mechanism that causes these high explosives to release that energy. Okay, so these guys, although they're very, very dangerous, they are very stable at the same time. So when you look at high explosives, you've got some of these that are single compound explosives, like ammonium nitrate. And ammonium nitrate, this is the explosive fuel that was used in the Oklahoma City bombing that killed 168 people. Imagine a box truck full of barrels and barrels of ammonium nitrate, all detonated at the same time. That's essentially what you have, what you had with that Timothy McVeigh used in the Oklahoma City bombing. You've got TNT, which is a very, very common used in rock quarries and individuals and companies trying to clear rocks and things like that. Cyanate, okay, RDX. So these are very, very single compound explosives. You can take a barrel full of ammonium nitrate and give it a spark, and you're gonna have a massive weapon on your hands. Okay, this, because of its explosive power, is highly, highly regulated. You're not going to be able to get your hands on this unless you have a very, very special license, or if you're with the government or something like that. So very, very explosive, dangerous type of chemicals here. Some of these guys here, the binary explosives, are a mixture of TNT with other types of explosives. Okay, they like using the TNT because it has a very low melting point. It actually, this high energy explosive actually stabilizes the binary explosive, the extra ingredient in the bomb that's also very dangerous. The TNT makes it more stable and allows it to travel better and allows it to have more potential energy. So, Amatol is TNT plus ammonium nitrate. Pentolite, TNT plus another chemical, PETN. RDX plus TNT plus aluminum powder. You're talking about, this is going to stabilize the ammonium nitrate and make it even more dangerous. Whenever it travels easier, you can mess around with it, you can jostle it, you can knock a barrel of it over, nothing happens until you give it that detonation, that spark. Plastic explosives. When you talk about some of the states of matter that you're going to find explosives, you've got solids, you've got liquids, and you've got plastic explosives that's in a plastic state and can be hand molded and made into various shapes without any serious risk. Again, when you start taking some of these different chemicals and you're making these binary explosives, it actually stabilizes the explosive ingredients until it's time to detonate them. These guys, the plastic explosives, are not going to explode unless you give them a spark or some sort of extra shock. Okay, just holding them and dropping them on the ground, that's not going to be the amount of energy needed to start these chemical explosives. Dynamites, and nitroglycerin is going to be one of the chemicals that you look up here for your assignment. Principal ingredient is nitroglycerin, and Alfred Nobel, the little 3-minute video that introduced this whole section, made a fortune off of making dynamite. Okay, taking nitroglycerin, which is very, very volatile, and stabilizing it into dynamite. It's an oily liquid which detonates by pressure, shock, or spontaneously above 50%. Okay, so you could take, in the video it says he dropped a beaker full of nitroglycerin onto the ground, which should have exploded and killed him. It didn't, which led him on this path to stabilizing nitroglycerin into dynamite. So, and then, from there, you got all kinds of different types of dynamites. But again, dynamite is nothing more than a combination of chemicals, in this case, nitroglycerin being one of them, where we stabilize the nitroglycerin into a substance that we can then package, that we can then store for long periods of time. And if you want to blow up your dynamite, you have to light the fuse, and that fuse provides the extra spark to destabilize the nitroglycerin, and then you got your explosion. Then you get your low explosives. Okay, the difference is these guys burn very quickly, but they don't explode very suddenly. Okay, your black powders, your gunpowders, a mixture of 75% potassium nitrate, charcoal, and sulfur. Okay, blasting, shells, igniters, propellants. These guys, low explosives do not explode suddenly. They burn very quickly. When you fire a handgun, and that shell casing, that cartridge casing, that's got the load of gunpowder. Again, inside the chamber of that gun, when that gunpowder burns, it produces those gases very suddenly. Not an explosion; it's a sudden burn, and that's what propels. It's all those gases that are produced that propels that bullet down the chamber of the gun. Chemical reactions taking place in such explosives are comparably slow, and their burning proceeds from the surface inward in layers at approximate rate of 20 centimeters per second. So this is important here. Comparatively slow, and it proceeds from the surface inward, whereas your high explosives are going to blow up, your dynamites, your plastic explosives, they're blowing up from the inside out. Okay, they're creating that's where you get the shock waves and those pressure bursts that come from in all directions. They're going from inside that explosive to outside in all directions. Whereas gunpowder, this doesn't do that. Okay, it just simply burns out in the open. If you get gunpowder and you put it on a table and burn it, it's going to burn very quickly, and it's not going to explode on you. Okay. So that is it for explosives here. What we're going to do here is I'm going to give you 4 different types of explosives and do a little research on each one of them. And this is going to be the last that we do for this week. Tomorrow. So when I give you the homework tomorrow on Thursday, this will be the last thing we do. So if you get a chance, you get this done, just kind of go back and try to work on some of those other assignments that we had throughout the week. And then we'll come back and we'll start on a new unit. Not sure what that's going to be yet, but we'll start on a new unit coming back next week.